Hello students, today we are going to learn about the theorems which are of circles. We will be doing first of all the angle properties of the circle, and all these I will be teaching you on the basis of how we apply them. We will not be doing the proving of the theorems, but what it means, what is the mathematical form we get out of it. So we start with the first theorem. The angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. First thing here, important is this arc. Arc of a circle, we have a circle here. This is arc of a circle, BC. Even this is arc of a circle. This one is smaller in size, so it is the minor arc, and this is longer in length, so it is the major arc. So what the theorem says, I have taken an arc BC here, minor arc. Theorem says the angle subtended by this arc at the center. So from the end points of the arc, we take lines to meet at the center, and this angle BOC is formed. Then it says the angle subtended by it at any point on the remaining part of the circle. Since we have taken this minor arc, this major arc becomes the remaining part of the circle. If I get angle made at any point over here, due to this arc BC, so I have taken a line BA and a line CA, both of them meet, and I get angle BAC. And the theorem says whatever is the angle formed over here will be double of over here. It means if this angle BAC is 40 degree, 40, so 2 into 40, this will come as 80 degree. Whatever will be the angle formed, always this relationship will hold between the angle at the center and angle in the remaining part of the circle. Another diagram based on this, where I will be taking major arc making the angle at the center. So I have taken a circle with center O, and this is the major arc BC. Now it is making this angle which is greater than 180 degrees, so this is reflex angle. So now remaining part of the circle is this. So I have to get angle made by the major arc BC anywhere over here. So I have taken a point A, joining BA and CA to get this angle BAC. Now, whatever is the value of this one, this angle, reflex angle BOC, will be twice of that. So, for example, if I say that it has a 110 degree, so if this is 110, double will be 220. So, this will come as 220 degree. Whenever you get sums of this theorem in a question, always try to take a look at this from two specific points. If lines are going at the center and lines are going at a circumference, then you relate always that the angle at the center is double of this. We have done the first theorem, now we move to the second theorem, which is a very important theorem. It gets used maximum number of times when you are doing the sums from the exercise. And theorem 2 says, angles in the same segment of a circle are equal. What is a segment? First of all, you need to know. I have drawn, this is the chord AB. The moment a chord is drawn, its circle gets divided into two parts. The smaller part is called as a minor segment, and the larger one is called as a major segment. So theorem says that angles in the same segment. So if I have taken this chord AB, I should make the angles either in the major segment or in the minor segment. I have made angles here in the major segment. So because of this chord AB, from the point A and B, line goes and meet at point C. So angle ACB is formed due to this chord AB in the major segment. Then I take one more. From the point, second point A and B, take it to the point D at the circumference. This is also the angle made by the chord AB in the same major segment. So according to the theorem, both of these will measure the same. So I have written here angle ACB, that is this angle, equal to angle ABB, that is this angle. Now we start with the third theorem. This theorem also will be getting used a lot. The theorem 3 says angle in a semicircle is a right angle. So this is a circle with center O. AB is a diameter. Now this AB diameter, the moment it is drawn, you get two parts, both are semicircle. Theorem says, now this is the semicircle part. If I draw angle from the points A and B anywhere over here or over here also, this lower semicircle, angle from will be 90 degree. So here I have from A, I have taken a line, from B I have taken a line meeting at point C. This angle will measure 90 degree. So the moment you get to see in a question that you are provided with a diameter, right? You see from the end points of the diameter, the lines are going and meeting at the circumference, you take that angle as 90 degree. So on the basis of the theorem, we get this result, that is angle ACB is equal to 90 degree. Now we will be seeing the cyclic properties of a circle. So continuing with the previous part, so I have numbered in the sequence way, so I am taking this as theorem 4. Again a theorem with a lot of use. Theorem says the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degrees. So first we need to understand what is a cyclic quadrilateral. You can see this is a circle drawn with center O. All the four vertices of the circle lies on the circumference. Then such a figure is a cyclic quadrilateral. I repeat, all the four vertices should be on the circumference. Then only it is a cyclic quadrilateral. Now, if I take angle A, angle B and angle D, for angle A are adjacent angles. But the theorem says regarding opposite angles. So, opposite to angle A is angle C. And according to the theorem, it says angle E plus angle C will be 180 degree. So if you know any one of the angles, you can find the other angle by using this property. Same way, if I take angle B, opposite to it is angle D. The sum of angle B and angle D also will come as 180 degree. So, a very important theorem. And how do you relate the sum, whether it will be used or not? The moment you see you are getting a quadrilateral with all the four vertices lying on the circumference, you take the opposite angles to add it up as 180 degree. And one of the angles is known, you can get it. Now we come to the next theorem based on the cyclic properties of a quadrilateral. Okay. It is also based on a cyclic quadrilateral. So again I will repeat before telling the theorem what is a cyclic quadrilateral. You can take a look. A circle is there. ABCD is a quadrilateral. The point A, B, C, D are lying on the circumference. So this becomes a cyclic quadrilateral. Now what this theorem says? An exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So, I have not drawn an exterior angle. I will be showing that exterior angle now. If I extend one of the side and if I extend one of the side and let us name and naming this point as E, so you get an angle from here which is outside this quadrilateral. So it becomes the exterior angle of this quadrilateral. Now this angle will be equal to the interior opposite angle. So how to take a look at interior opposite angle? Just go to the adjacent angle to this and then move to the opposite one. So that is angle D. These two angles will have the same measurement. So if this angle is, for example, taken as 65 degree, this angle will also be measuring 65 degree. So let us write. So as told, this angle CBE will be equal to angle ADC or angle D. So this is your last theorem for the cyclic property. Thank you.